Hi everyone. Today we are going to start Unit 7, Right Triangles and Trigonometry. So this is day 1 notes called the Pythagorean Theorem. So the first thing they would like us to do is draw a right triangle ABC with a right angle at B. So if you start out with a horizontal segment and then draw a vertical one and then connect those, I'm going to put my box, and it said to label the right angle at B. It doesn't matter where we put A or C. So in a right triangle, there's one side that's really important, and it's called the hypotenuse. It is line segment AC. It is always across from the right angle. It's always the longest side, and usually it's the one that's slanted. So remember, in any triangle, all the angles add up to 180 degrees. But a right angle is always 90, which means there are 90 degrees left over for the last two acute angles in this triangle. So if the measure of angle A is 30 degrees, that means the measure of angle C must be 60. And the way I got that was the remaining 90 degrees minus the 30 we already have is 60. If angle C is 45, that means angle A has to be 45. Again, 90 minus the degrees we already have, there's 45 degrees left. If angle A is 25, and I do 90 minus 25, there are 65 degrees left over in angle C. If angle C is 73 degrees, 90 minus 73 is 17. And if angle A is 64, 90 minus 64 is 26. So, what do you notice about the measure of angle A and the measure of angle C? They always add up to 90 degrees. So the measure of angle A plus the measure of angle C is always 90 degrees. Now there's a name for this. We learned it way back in the beginning of the year in Unit 1. They are called complementary angles. So angle A and angle C are complementary angles. So pretty much it just means they add up to 90 degrees. So I just said the same thing 3 different times. So that's pretty important. So let's take our highlighters. I don't care which one you know, but you need to know one of these 3 facts. They're all the same thing, just stated differently. So those are very important. Okay, there's not much to memorize in this whole unit, but that one fact is pretty important right there. So we're going to start with another picture of a right triangle. I know it's a right triangle because I have my little box in there. It means these 2 sides are perpendicular. And it says label the sides A, B, and C. C is going to be the hypotenuse. So again, it's across from the right angle. It's always the longest side. Usually it's kind of the slanted one. The other 2 sides, doesn't matter which one's A or B. So the famous Pythagorean theorem is stated A squared plus B squared equals C squared. A and B are called legs, and it doesn't matter which one's which, but the important one is the hypotenuse. So the hypotenuse is always by itself over on the right-hand side of the equal sign. Now, this is a very famous theorem. This works forward and backwards. So here's what I mean. Let's say you're trying to build something, and you have a piece of wood going this way and a piece of wood going this way, and you want to know if this is going to be sturdy and stand up straight. You need to know if there's a right angle. Well, the Pythagorean theorem works backwards. So if you were to take the length of one side and square it, and the length of the other side and square it, and add those together, and then measure from end to end, those sums squared has to equal the hypotenuse squared. So it works backwards. So if A squared plus B squared equals C squared, then you know you have a right triangle. And in fact, a lot of builders will do this. They will check. They usually, they'll measure 3 inches out, and then they'll measure 4 inches out, and then they will measure diagonally and see if that's 5 inches. Because 3, 4, 5 is something called a Pythagorean triple. It's the most famous Pythagorean triple because these numbers work in the Pythagorean theorem. 3 squared is 9, 4 squared is 16, 5 squared is 25, 9 plus 16 is 25. So builders do this all the time. They'll just measure out 3 inches, put a mark, measure out 4 inches, put a mark, measure diagonally, and see if it's exactly 5. And if it's not exactly 5, then they can, adjust the slope of one of these two sides to get it to be exactly 5 inches. So that's how they do it. So it's very famous. So this theorem goes both ways. All right, let's flip. Let's do some real life examples now. All right, so we have a picture of a house here. There's a whole bunch of junk on the ground here, and here's a ladder leaning up on the house. So it says a ladder, or a 15-foot ladder, 6 feet away from the base of the house, is leaning against it. How far up the house does it reach? So things like this, you got to train your brains to look for right angles and look for right triangles. So in the picture here, the ladder up against the house and then the distance away from the house makes a right triangle. So when you have a right triangle, if you have 2 lengths, you're always going to use the Pythagorean theorem. So the ladder's 15 feet, so that goes here, and it's 6 feet away from the base of the house. The house is standing up straight, so here's your 6 feet, and it wants to know how far up the house it's leaning. So again, anytime you have 2 sides of a right triangle, you're always going to use Pythagorean theorem. So Pythagorean theorem is something squared plus something squared equals something squared. The important number has to go here, the hypotenuse, so the 15 goes here. It doesn't matter where the x goes or the other number. So then we're going to solve. 6 squared is 36. 15 squared is 225. So then to solve an equation, you want to get the variable by itself. So we are going to subtract 36 from both sides of the equal sign. So 225 minus 36 is 189. Now to solve for x, you have to undo squaring. And the opposite of squaring something is to take a square root. Now every time you take the square root of a number, there's actually 2 answers, a positive number and a negative number. But since we're measuring for height, we don't want the negative answer. Now if you type this into your calculator, so second square root and 189, remember, just kind of be aware of where your cursor is. I'm done typing, so it doesn't matter. So it is this decimal. Oftentimes, these square roots are irrational, which is a decimal that's going to go on forever. So you kind of have to use some common sense, or the problem's going to tell you what to round to. So we want to know how far up the house does it reach. So we could say about 13.7, and the units were feet. This is a symbol that means approximately equal to 13.7 feet or 14 feet, something like that. So technically, those are all answers. This is the most accurate because it's the entire decimal. All right, let's check out just kind of a more basic geometry example. All right, so find the value of x. So I'm seeing a little box. Oh, right triangle. So here is a right triangle. One side is 3, one side's x. But if I look carefully, this big triangle is isosceles. There's 2 equal sides. So if I just need this bottom length and this whole thing is 2, I know that this is just 1. An isosceles triangle, this is your altitude. It's perpendicular to the base. It bisects this angle up here, and it also bisects this segment, which means it cuts it in half. So now I have my right triangle to work with. So again, I need a squared plus b squared equals c squared. I have 2 sides. The hypotenuse is the important one. It doesn't matter where the other 2 numbers go. Just remember to square them. So again, we're going to solve. 1 squared is 1. 3 squared is 9. You're going to end up subtracting. And then you take the square root. Now this said simplest radical form, which is something that is not often used in geometry, but I wanted to show it to you anyways. So that means we need to break down this square root of 8. So you got to think of what 2 numbers multiply to 8, and one of them needs to be a perfect square. So perfect squares, here I'm going to make a list over here. are just numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, I'll go up to 10. And then if you square them, 1 times 1 is 1, 2 times 2 is 4, 9, 16, 25. You should be pretty familiar with these numbers. Like I can talk and figure them out at the same time. This column are all perfect squares. So 8 is not in that list, but 4 is. And square root of 8 could be written as the square root of 4 times 2. Now you can break up this into 2 separate square roots, and the square root of 4 is this number 2. So final answer for this, that square root of 4 becomes this whole number 2, and square root of 2 is irrational. So this is what it is in simplest radical form. All right, Linda is designing a circular piece of stained glass with a diameter of 7 inches. All right, so we're starting with a circle. Oh, pretty sweet circle. That's a little off. So the diameter is 7 inches, so that goes all the way across. Now, it can go at any angle. There's an infinite amount of diameters. So I'm not going to draw any yet. She is going to sketch a square inside the circular region. All right, so square, I know, has 4 right angles, and all 4 sides are congruent. Now, if I want to draw on this diagonal, or the diameter, I'm actually going to go diagonal through this circle. And do you see what we now have is this beautiful right triangle. So your diameter is 7 inches. To the nearest tenth of an inch, find the largest possible length of the side of the square. Well, I know both sides are the same. So I again can use Pythagorean theorem. So my hypotenuse is 7, so that's going to go on the other side of the equal sign. Now this is tricky. X squared plus x squared. A lot of people think it's x to the 4th, but x to the 4th means x times x times x times x. That's not what this is. So usually if I put the 1s there, then people know this is 2x squared. 7 squared is 49. To solve for x, we're going to divide both sides by 2. 49 divided by 2 is 24.5. And then we're going to take the square root. Now, it said to the nearest tenth. So, go to your calculator. Square root of 24.5 to the nearest tenth. So, I'm just going to write down a few of these numbers. It keeps going. This 9's in the tenths place. You always look one number to the right. If this is 5 or above, you would round this up. If it's 4 or below, you leave it alone. So the answer to this problem is 4.9, and everything was in inches. Yep, it's off the page. There you go. Okay. Darius is building a shed where one wall is 12 feet long and another is 14 feet long. If the length between the two ends is 19 feet, are the walls intersecting at a right angle? So here's Darius building a shed. So I kind of superimposed this black triangle here. So pretty much what we got going on is one side is 12 feet long, the other side's 14, and then when he measured, he got 19. He wants to know if he has a right angle. So we're going to check to see if these numbers work in the Pythagorean theorem. So 12 squared is 144, 14 squared is 196, 19 squared is 361. If you add these now, you get 340. That does not equal 361. So no, they are not intersecting at a right angle. Which means his shed is not going to be sturdy, and due to wind and pressure, it'll eventually fall over. So that's not good. So his measurements are off. He needs to adjust. He needs to move one side in or out to get a better angle. Okay. All right, what's up with this problem? Why is this on Pythagorean theorem notes? So let's check this out. Let's plot. It wants the length of line segment AB. So A is 1, 2, -4, 5. And B is 6, -3. So I'm just going to grab a ruler and connect these. And here's my A, here's my B.